Let's continue system design. So in the last session, we just talked about our load balancing, how our systems are managed high volume traffics and routed the request to the different server, and that is different types of load balancer we have to discuss in the layer 7, layer 4, global servers routing for the virtual load balancer, software load balancer, hardware load balancer, DNS based load balancer, and IP based load balancer, application based load balancer. So, and couple of lots of we discussed. There are some challenges, some advanced, some real world application as well as. Today, let's talk this load balancer, how they are deciding, what are the algorithm they are using. So this is the load balancer. The request come here, and this go to, let's go, this is the server 1, this is server 2, server 3, server 4, server 5, server 6, lots of server. So how this load balancer know this request I am going to divert this server or this server or this server? How this load balancer know? So for load balancer, we have to give some intelligence. This means some algorithms. So load balancer have some predefined algorithm, so that load balancer know if from whatever the user input requests come, from whatever the information they carry, from this information, what kind of algorithm I have to play to know, hey, this request is handled by this specific server. So this is known as a load balancing algorithm. So today we are going to talk couple of, you can say, dozens of load balancing algorithm exist in the market. Okay, but I am going to discuss couple of them, so you should aware, hey, these are the different types of algorithm exist. So whenever you are going to use any load balancer, you have to properly configure, hey, this kind of situation, this kind of algorithm I am going to tell, hey, load balancer, you play. Okay, so load balancer algorithm is a very key, because this is need to configure by your DevOps team, your system designer, your architecture. Tell us, hey, this kind of routing I want. So let's discuss couple of load balancing algorithms. Okay, so load balancing algorithms. So as I mentioned, load balancing algorithms are used to distribute workload across the multiple server to improve the responsiveness, reliability, and scalability of my application. So if our load balancer use such algorithms, so that our application become responsiveness, reliability, and scalability. And this algorithm also help us to load balancer, so no single server is going to overloaded with the request, and also preventing server any crash, slow response time, and other performance issue. So whatever the load balancer we are going to use, we have to put intelligence to the load balancer. They can become a responsive, reliability, scalability, and also ensure that no server is going to very slow, no going to the, if someone server going to the crash, or some server going to very high loaded, then how load balancing play a very diplomatic, very intelligent role here. So those intelligence of the load balancer due to the load balancing algorithms they are going to use. So couple of algorithm I am going to talk, so you should aware this kind of a load balancing algorithm exists in the market, and while configuring load balancer, we have to keep this algorithm in a mind. So first and most basic algorithm is known as a round robin algorithm. Round robin algorithm is, let's say this is the server 1, server 2, server 3, server 4, and just say, hey, load balancer, whatever first request come, go to the here. Whatever the next request come, go to the here. Whatever the next request come, go to the here. Whatever the next request come, go to the here. Whatever next request, again go to the here. So sequentially first this, again this. Round robin, one by one, every server get a proper chance. So here say, each incoming request forwarded to the next available server to predefine the sequence. I define this is my first server, this is my second server, this is my third server, this is my fourth server. So this kind of algorithm is very simple and easy to implement, doesn't require any kind of a server information. Just okay, hey, these are my server specific sequence. So for example, let's a web server. I have a 3 backend server A, backend server B, backend server C. So similarly, first request go to the server A, second request go to the server B, third request server go to the C, and again fourth request go to the A, fifth request go to the B, sixth request go to the C. So in this way, round robin, very simple, and they are ensuring that whatever number of requests you receiving, every servers are getting the same kind of load. So this is a very simple. Maybe someone can use round robin algorithms. Next, similarly, sometime you can say list connection algorithms use. What do you mean here? So here say incoming requests are directed to the server with the fewest active connection. So here our load balancer receive the request, and here a couple of servers, couple of server. Might be this server are handling at a time 5 requests. These are handling 1 request. These are handling 2 requests. These are handling maybe 3 requests. So notice these are the very list number of you can say fewest active requests is going on. So this new request again go to the whatever the server have enough bandwidth available. So least connection. So whatever the less number of active session going on, new requests going to type, because this is already 3 requests, 2 requests. They have only 1 request serving. So this server have a more space, more capacity available. They can handle the another request. Okay. So these kind of algorithms also we can use, and that they reduce the load on the busy server and prevent them from the becoming a overwhelmed. So this algorithm ensure that the particular one server is not going to overloaded. More requests go to the one. Even other server are free. Other server have a lots of space, lots of active connections free. And for example, a server has a 10 active connection, while another server has a 5. Another next coming go to the 5 connection, because this A server already have a 10 active session going on. So next request not go to the make 11, because another server only have a 5 active requests. So let's go to the next request, go to the active server which have a 5 number of open connections. So these are also very kind of good algorithms where they are ensuring that the particular server is not going to overload it. Similarly, some kind of algorithm may be IP based, IP hash algorithms. So here say whatever the incoming requests come directed to the server on the base of client's IP event. So whatever requests come, notice whenever requests come, always requests come from the IP address, from which IP address this request is coming. So those informations, this load balancer already have this request come from this IP address. So from this IP addresses, they are going to direct. So generally provide the session persistence. I already talked session persistent, and as a client are always sent to the same server, because if the particular server any request come go to this machine, the next request come from the same machine go to the same server. So in this way, generally, let's from my laptop I am accessing my Facebook. So Facebook server load balancer, no, this is the IP address from where the request come. The next I say I am clicking on the next page, I clicking on the next post. So each request go to the server. So our Facebook load balancer know, hey, this request from the same IP address. So we can maintain your request always direct to the same server. So this is the way client based route, you can say. Example, let's say this is my client IP address, like 1.100. Always route to the server A. If any client IP address may be 200, they are going to the always route to the B address or some C address. So depend upon the IP address, you can say requests are routed to the specific server. So sometimes we are also configure this IP based routing also ensure that key same client, same user requests go to the same server. And sometimes you can use the geographical location algorithm, like hey, requests come from directed to the server based on its client geographical location. So this also very good kind of algorithms, and this reduce our latency, because our request is go to the nearest region from where the request is coming. So let's example, one client is from the North America, send a request to the server. So by default, our routing algorithm, so he know this request come from the North American region. So let's route directed to the located the United States, and another clients may be European, may be located to the Germany. So depend upon the geolocations, our routing algorithm decided, hey, this request come from India, let's direct to the nearest data center. This request come from the USA, direct to the this server. This come from the Germany, direct to this server. So sometimes we are also configure our load balancer can work on the basis of geographical location, and this algorithm reduce our latency. Our application is more responsive because our applications are serving data from the nearest data center from where the request is generated by the client. And sometimes also we are using the least response times. So might be this is our load balancer, okay, and a couple of data backend server available. So if this the response time, this response time, this response time, this response time, so whatever the least response time, our objective, our response should be as quickly. If this server is so quickly response, our route go to the least response server. So incoming requests are directed to the server with the fastest response time, means the which servers are responding very quickly. That means they have a lots of enough, they have a powerful, they have lots of capacity available. So this help us to client receive the fastest possible response, because here maybe our server one server response time is a 500 millisecond and another server is 100 millisecond. So by default load balancer prefer to route the call in the server which are the 50 microsecond response time, because they are quickly responsive. So sometimes we are configuring our load balancer on the basis of his response times. Whatever the servers are very quick response, let's load balancer going to route the call to the user session to the specific server. And I already discussed sticky session or session persistence algorithm as well. So here simply, if my request always go to the specific server, because the load balancer have a background couple of servers, server 1, server 2, server 3, server 4, server 4. First request I go to the here, the next request, next request, next request for the same user. My one user, generally whenever you log in any application, you can do multiple, by default you are not doing, but internally our front end applications are doing the multiple requests to the server. So all the servers generally directed to the specific one server, so that the response times is fast and data collections is also very sticky. So here, so whatever the incoming requests come from a specific server directed to the same server handled by the client previous request. So this is ensure that client sessions are maintained across the multiple requests. Generally client login request go to the send server A, and subsequent all the requests go to the server A, so that they can maintain the client session. So generally session sticky session or session persistent algorithms are also used to maintain the client previous calls. You can say huge list, I am not going to talk, let's couple of more, like predictive load balancing algorithm. Incoming requests are directed to the server based on the predictive analytics rule, such as the historical traffics and the future demand. So this kind of algorithm ensuring that resources are allocated efficiently and client receive the best possible response. So here our generally load balancing algorithm use some predictive algorithm, maybe some historical data or traffic to the website increase during the holidays, or some predictive load balancing algorithm request to additional load. I know, okay, hey, this is the date coming on, and every month on the date of the first second are very high load, and every month like in the end of the month high load going on. So accordingly they are decide, hey, I am going to divert our request to the maybe new server or the server which are very freely. So you can say I cannot discuss here the load balancing algorithm is list is very huge. Just Google it, hey, load balancing algorithm, you find all these algorithm and more and more and more. But I'm just clubbing some of them with the which we discuss and which might be have not option to discuss, but you should aware couple of them more. So all the which I discuss, maybe round robin algorithm, list connection algorithm, IP based geographical location based list response time, this is known as your traditional algorithm. Generally these are the algorithm, and sometimes these are the, you can say, advanced level of algorithm, like we not discuss, but observe server state. Let's observe the server state, what the health, what something, and according to our load balancer going to take decision. Similarly, less least bandwidth or some ratio based or percentage based, or here we discuss a session persistent or a two-way list algorithm. So these kind of algorithms you can find that help as an advanced level of algorithms as well as. And similarly, if you talk some nowadays due to the AI and machine learning based algorithm also, so we are some machine learning based algorithms where the we are going to say, hey, load balancer, we can apply some deep learning, yeah, neural network or fuzzy logics or genetic algorithms already we have available. So we say, hey, reinforcement learning as well as, so lots of kind of load balancing algorithm available that's use the machine learning based concept, like genetic algorithm, yeah, fuzzy logics based or neural networks based. So these are the different kind of algorithms that's our load balancer can use to decide to routing his traffic to the respective server. Even more, if you some more algorithms, maybe simulated algorithm, Tabu search, like river formation, immune system algorithm. So lots of kind of nature based inspired algorithms where you can apply how these algorithms. So you can say load balancing algorithm is a very huge list. I cannot discuss everything, but just pointer, hey, you should aware whenever sometime you are using the distributed kind of system or multi-agent system. So for distributed or multi-agent system, these are the load balancing already available for distributed load balancing algorithm, multi-agent load balancing algorithm, well, maybe cloud sourcing, maybe gaming theory, some different algorithm available. You have to just aware, hey, this while configuring your load balancer, you can select this maybe multi-agent based or distributed algorithm. And even more and more, we cannot talk everything, just other basic example, but you can just Google it for load balancing. A huge list of algorithm available, like we can use the adaptive algorithm or predictive algorithm or maybe stateful algorithm, which I discussed already. So these are the kind of some other algorithm you can use according to the use. So here the objective of the load balancer algorithms, you have to look your requirement, your use cases, and what kind of algorithms you want to configure your load balancer. Good options here, you are not going to write these algorithms. Whatever the load balancer you are selecting, load balancer already give you the configuration. You just go configure, hey, this load balancer here, I want to session stacking kind of a load balancing. Just to, if I using the cloud provider load balancer, they offer also lots of configuration, or any load balancer you are using, they are offering, you can just configure them. You can just tell them, hey load balancer, I want round robin kind of load balancing they are playing. So good option. You should aware as a system designer, as a architecture, as a architect of the system, you should aware for this scenario I am going to apply the round robin algorithm or list connection algorithm, या session persistent algorithm, or percentage based routing, or ratio based routing, or over depend upon the response time based algorithms. Just you configure, load balancer is capable to do this. So good things, everything is already in place, load balancer is already placed, algorithm is already placed. You as a system designer, you should aware, and while system designing you say this is the place where I am going to apply the load balancer, and this load balancer can be configured with this algorithm. Just this is your responsibility. And while selecting load balancer, while selecting load balancer algorithm, we as a system designer, our responsibility, we have to take both angle. What are the positive scenario and what are the negative scenario? Positive scenario, everything work fine, that's good. What happened in the negative scenario? Because system, the load balancer is the single point of failure, so you have to think how we can make resilient scalable load balancer as well. As due to that, notice the Amazon using the elastic load balancer. They can also not very strict fix, they can also replaceable. Hey, so maybe you are going to some primary load balancer, one is the secondary load balancer, both are point to the one virtual IP address. We request client are just using the virtual IP address, everyone can just using this application internally. First time all the loads go to our active or master kind of a load balancer, and later part if something happens, something problem happen, all the load diverted to the next kind of a load balancer. So you have to properly configure and manage load balancer. If you are not thinking, because this is the major problem, is the single point of failure. Your whole distributed scalable applications are rely on the one load balancer, because every request across the globe coming on your load balancer. So your load balancer machine is very powerful, not generally crash, not fail. If something failed happen, if something crash happen, then you have an alternative available, so that your system cannot be stopped. Somehow your system should be highly available. So hope this information help you to select good, according to your context, the right load balancing algorithm. Thank you for watching this.